everyone. So today we are going to solve problem number 403, frog jump on LeetCode. So let's first read the problem statement. So the problem says a frog is crossing a river. The river is divided into some number of units, and at each unit there may or may not exist a stone. The frog can jump on a stone, but it must not jump into the water. So till here we understand that the frog can only jump from one stone to another, and there might be some water and some stones. So suppose here is water and here is stone, then here is water, then on 4 there is a stone. Next, given a list of stones positions in units in sorted ascending order. So this is to be noted that the position of stones are given in ascending order. Determine if the frog can cross the river by landing on the last stone. Initially the frog is on the first stone and assumes the first jump must be, so this is to be noted, must be 1 unit. So here it should be 1 only, 0 to 1 in the forward direction. When if the frog's last jump was k units, its next jump must be either k minus 1, k or k plus 1 units. The frog can only jump in the forward direction. So what the problem statement means is the first jump is 1 units and the size of the jump is given by k. Next, from here he can have a jump of 0 units, 1 unit or 2 unit. This is k minus 1, k and k plus 1. Similarly, from 3 he can move. So when he jumps on 3, the value of k becomes 2. And when he tries to jump from 3 to 5, the value of k here is 2. Basically the difference is 2. So yes, he can jump. So now the value of k still remains same. Next value is 6, 8, 12, 17. So can you jump from 5 to 6? Yes, he can, because it's k minus 1. So value of k will be 1. From 6 to 8, yes, value of k will be 2. From 8 to 12, no, it's not possible. So we try another jumping position. Can we jump from 5 to 8? Yes, we can directly jump with value k equals 3. And can we jump from 8 to 12? Yes, now we can jump with k equals 4. And from 12 to 17 we can jump with value k is equals 5. That will be the previous k plus 1. So the problem is quite simple. So we need to see how can we solve the problem. So first we look at the constraints. This is 2000. So by looking at the constraints we can easily say that it is a DP problem. Also in the examples we have seen we have to try out every possibilities. So we will try every possibilities using recursion and then we will memorize our solution. Recursion plus memorization equals TP. So this is what we have to do. So how can we write the basic function for this? So what we require here is an index and the value of k, and next we see if we reach the last index, then we say that yes, we have reached here, so we return true. So this will be our base case. If index equals last and the value of last will be stones dot size minus 1. So if we reached here, we will say we return true. So this is our base case. And what we'll do in the rest, so if you have at index ind, so we will loop from here. I will be looping from index to less than length, or you can say less than last, and at each step we will increment I by 1, and we'll only call for the children, means we'll only jump if the difference in this element and the previous element, next element, will be either k minus 1, k, or k plus 1. And also we know that if once the gap is crossed, so let's first write, we'll declare variable gap. This gap will be stones at current index, that will be I. This will transfer from index plus 1, because on index you are already standing, so from index plus 1 till the last. So the gap will be stones at I minus the current stone, and we can observe if this gap becomes greater than k plus 1, then it will also be greater than k plus 1 for all the remaining elements, because the elements are given in ascending order. So if once the gap becomes k plus 1, it will always be greater than that. So once this crosses, we need to break this loop, and if this gap is less than or equal to, if this gap is greater than equal to k plus 1, we will need to check the value if it's possible or not. So we will take a boolean here. Boolean current will initialize it with false, and we'll try to jump on every possible stone, and we will take OR of the result. So f of I, so index will become I, and what is the next value of k? It will be gap, because this is the length the frog is jumping right now. And at the end we need to return current, and then we can simply memorize this. Sorry, I'm writing sideways. I'll try to improve it in further videos. So now let's see how to code it. So what we need is, so we first need to address the first condition, that is the first jump is only of length 1. So if stones at 1 minus stones at 0 is greater than 1, that means the difference between given stone and the first stone is greater than 1, we simply need to return false. Next, we will make a utility function, bool util. It will require our vector of int stones and an index variable and a k variable. Next, we know if index equals stones dot size minus 1, that means if we reach the last index, we will return true. And next we will declare bool current false. Now we need to try to jump on every possible stone we can from current index. So we will loop starting from index plus 1 I will be less than stones dot size I plus plus, and next then we calculate the gap. Its gap will be stone set I minus stone set index. Then we'll check if gap becomes greater than k plus 1. We'll simply return false. Now we'll break it. We don't need to return. We will break from here because the further stones will also have gap greater than k as it is sorted in ascending order. Then we need to check if gap is greater than or equal to k minus 1. Then only we need to jump on that stone. So we will jump and take the OR of the result, which will be util the stones index plus, so I will be index, then gap will become the next k, and at the last we need to return the value of current, and here we will return the value returned by utility function stones, and we are jumping from first stone because the 0 to 1 jump is fixed, so we will try jumping from first stone, and the value of k for this will be 1. So let's see if sample test cases are passing. So sample test cases are passing, but looking at the constraints, we know it's exponential solution, so we will try to memorize it. Simply we'll make vector of vector dp, and then we will resize it. The size of index will go from 0 till size of stone, so we will stones dot size, and the value of k will also go from 0 till index, because although the value of stones here is quite high, but we know at each step the value of k can maximum increase by 1, so the value of k can also be 0 till the length of the stones only. So it will be vector int stones dot size, and we'll initialize -1 because this will not be a possible answer. Then after here you simply need to check if dp at index and k is not equals -1. We will return the value stored in dp, so dp at index and dp at k, and at the end we need to memorize it, so dp at index and k will be current. What we have done, we have first checked here the jumping from 0 to first stone. If it's greater than 1, we simply return false. Then we resize the dp and call our utility function, and if we reach the last index, we say yes, we reached here, and we return true. We check if the value is stored in the dp, and we return if it was stored, and then we initialize current equals false and try out every next stones that are present, and for each stone we calculate the value of gap, and if the value of gap becomes k greater than k plus 1, we break out of the loop, as the next stones will also have the gap greater than k plus 1. Then if check if gap is greater than k minus 1, then we jump on it and get the result from there and OR it with our current result, and finally we memorize it and return the solution. So it was very simple. Let's see it if it's running. Yeah, so it's running quite well. So now let's analyze the time complexity of the solution. So the time complexity is very simple. Here we are moving k time, or we can say we are moving x times. So let x be the size of the stones. So the time complexity will be x square and the space complexity will be big of x. So thank you and see you in the next video.